So until we could see things that were smaller than what we could see, there was no study of microbiology. So there were three major things that led to the development of microbiology as a science. What's the first one? A microscope, yeah. Okay, early development of the microscope is discussed in chapter 1. But I'm not going to just leave it at that. Okay. There was a guy, whose picture is in your textbook, Anton, von Leeuwenhoek. The mouthful. Now, you ever watch that show? See there? I can't remember either.
Not the one on parasites that, or the ones that live in us, the monsters in us?
Yeah, Monsters Inside Me. I watch
That's
that.
a cool
No, this
show.
is actually an auction show. And it hasn't been on in so long that now I can't remember. But there's a woman named Leslie, and she runs an auction. And she says something like, last warning, you know, making the bids is final warning. Anyway, she explained on this auction show, this is where I learned this, on TV. If you have a Van or a Von in front of your name, that means you're high society. You're from a wealthy family, you're high class, wealthy family. So von Leeuwenhoek was a wealthy guy. And of course, wealthy people only married other wealthy people because they just didn't hang out with just anybody. They only hang out with their own social class. So his wife was very wealthy and from a wealthy family too. So she gave him as a gift these pieces of ground glass, which we might think of as like a magnifying lens. So they were convex and concave filed pieces of glass. And Van Leeuwenhoek worked with them and looked at things and modified them and fashioned them into the early microscope. Now what Van Leeuwenhoek created would be what we would call a simple microscope. Simple because it only has one magnifying lens. And that magnifying lens gave magnifications of 200x, maybe 300x. Different accounts I read, some say 200, some say 300. If we had our microscope upstairs, we have a revolving nose piece, and it's got 4 magnifying lenses on it. It's got scanning power, low power, high dry power, and oil immersion power. If I took one of those lenses and just snapped it off and looked at it like that, well, that would be kind of be like what Van Leeuwenhoek had. But our microscopes actually have another magnification lens inside the eyepieces. So our microscopes are actually compound. The reason they're compound is because it's more than one set of lenses. So one magnification compounds the magnification of the other. So that's why when you calculate your total magnification, you have to multiply the ocular lenses, which is always 10x, by the objective lenses, which are the lenses on your revolving nose piece. So your ocular power is always 10x, your objective power for your scanning power is 4x, your low power is 10x, your high dry power is 100x, and your oil immersion power, your high dry power is 40x. See there? I can do it too, make boo-boos. And your oil immersion lens is 100x. So your total magnifications are 40x when you're in scanning power, 100x when you're in low power, 400x when you're in high dry power. And when you go to oil immersion, you go from 400x to 1000x. So that's 2.5 times more than it would have been. So if you see a specimen really well in 400x, you might decide, okay, I'm going to stop here. That's it. That's the best I want to see him. But when you're looking at bacteria, and this will be a test question, you're gonna have to use 1000X. You use oil immersion to look at bacteria. And when you're doing your microscopy upstairs in the lab, and you look at it in 400X, you're like, yeah, it's good, I see it. And then you turn to oil immersion, and you'll be like, wow, now I see it a whole lot better. Okay. Another test question you'll have. Even though bacteria are really small and you're going to use 1000X to look at them, guess what? You're still going to start your focusing process in the scanning power. You're looking at a dog flea, heck of a lot bigger than bacteria. You're going to start in scanning power. Whatever you're looking at, you're going to start in scanning power. That's why it's called scanning power. Because you're going to scan the slide until you see where you think the thing is that you want to look at. Then when you find it, then you're going to turn to your next high power and use your fine focus to sharpen it up. Then you're going to turn to your next higher power and use your fine focus to sharpen it up. And then if it's a small enough critter and you want to look at it in 1000X, you're going to add your drop of oil, move it into the oil immersion lens, and fine focus to sharpen it up. So you're always going to work up stepwise. Your lenses are parfocal. That means once you have it in focus in one power, it's automatically in focus in all the other powers. So get it in focus in your scanning power, it's automatically in focus now. You're good to go. Don't move your stage. If you move your stage, you're now bringing it out of focus. Why would you do that? You just brought it into focus. It's in focus. Leave it the hell alone. Don't move the stage. Just go to your next higher power and use your fine focus to sharpen it up. That's all you have to do. And that's because your lenses are parfocal. You know, if you don't do it that way, it's not going to work out right. If you do it that way, it still might not work out right. Go back to the beginning and start over again. That's all you have to do. Takes a little practice. You'll get used to it after a while, but you're never going to get used to it unless you actually do it stepwise. And the other thing is you've got to force yourself to look through your eyepieces with both eyes. Some people are like this. Well, I don't want you to graduate looking like Popeye. Straighten that out. So you've got to force yourself to look through both lenses with both eyes. And you're like, I can't, I see two circles. That's right, because your brain isn't used to it. You have to train your brain. And the only way to do it is to force yourself to look with both eyes. And you'd be surprised, it kicks in pretty rapidly. Your brain catches on pretty quick. Sometimes if you wear eyeglasses, it can be more difficult. I just take my glasses off and let the microscope be my eyeglasses. I guess depending on what type of vision problem you have, that may or may not work, but that's what works for me. Okay, so how about this? Are our microscopes binocular or monocular? Binocular. If it's got two eyepieces, it's binocular. If it's got one eyepiece, it's monocular. Okay, so Van Leeuwenhoek had a very simple microscope, and he would look at all kinds of things. Let's see some of the things he looked at. Oh yeah, I have some I could give you up in the lab. Pepper. You go to the kitchen cupboard, you get out your pepper shaker. Put some in a cup, add a little water, push it up a little if you feel like it. You don't have to, but you could. Cover it so no dust or dirt or anything gets in there. Set it aside. After a few days, there'll be all sorts of good stuff swimming around in there. Because pepper is from nature. It's a seed. There's critters all over it. And in your pepper container, they kind of go dormant. Put them in a cup of water, and after a while, they'll start coming back and doing their thing. So I actually made a pepper infusion, and I have it upstairs, and you can play with it. He also did tooth scrapings. How many people are going into dental hygiene? Nobody's not. You're going into dental hygiene. It's a big thing in dental hygiene. Take some scrapings from the patient's mouth, mix it in a drop of water, slap on a cover slip, show it to the patient on a computer screen. In the lab too, I have a microscope that's hooked up to a camera, and the camera goes to the computer, and then you can show your patient, this is the crap that's going on in your mouth. And usually they use phase contrast microscopy for that. And might be a good time to tell you about bright field, dark field, and phase. Yeah.
Can I go back just for a quick second? I want to make sure that I have it written down with the way it was on the board. The protozoology and the phycology, those are other sub-disciplines, right?
Yes.
They're not
Right.
linked with the.
And phycology and protozoology actually overlap in the area where algae are protista. Good observation.
Okay.
Yeah, so they're just, so how you use the term, but just different terms for different things. So phycology, study of algae, protozoology, study of protozoa, and they can be subdisciplines of microbiology. All right, so we're talking about Van Leeuwenhoek, I haven't forgotten. Some of the things he looked at were pepper infusions and tooth scrapings. Because, okay, Van Leeuwenhoek, got your book out, what year was he popular, like 1816 or something like that? Or 1618? I don't know. 1632, okay. All right, they didn't really have like Oral-B self-flossing toothbrushes in those days, or the spin brush, or anything. Even the wealthy people, the mouths, not so clean. Oral sex, not real popular back then. Hygiene just wasn't there yet. In fact, I was watching a thing on TV about St. Valentine's Day and all that stuff, and in those days, they considered childbirth to be disgusting because the baby came out right between where you urinate and defecate. So they're like, that's gross. So anyways, how did I get off on that tangent? Anyway, so when we use bright field microscopy, what the heck do I mean by that?
There's a contrast between a dark surface and a,
Well, now you're like phase contrast.
okay.
Bright field means your field of view is bright. You have a light on. So bright field microscopy, you're going to have your light on. You can adjust your light. I mean, you can dim it down or whatever, but you have the light on. Okay, if I turned the light off in this room, and it was pitch black in this room, I wouldn't know that she had on a coral-colored shirt, and she had a red shirt, and she had a dark navy shirt, and he had a green shirt. With the light out, you don't see color. So in bright field microscopy, it makes it easier to see things if they have color. And that's contrast that you're talking about. So if your specimen has color, and you're looking at it against a glass slide, maybe in a drop of water, it's going to be easier to see. That's contrast. When you're in bright field microscopy, you're probably going to be using stained slides because that gives your specimen color. If you put a bunch of cells in a drop of water, put a cover slip on it, glass slide, glass cover slip, water, cells are mostly water, it's going to be kind of hard to see where your specimen is. If you stain your specimen, it's going to be a lot easier to see it against the glass slide. And when you use stain, you usually use bright field microscopy. There are no rules. You can use your microscope however you want, that you think you're seeing things the best. But in general, that's the way it works. So your field of view is bright. Then there's dark field microscopy. Now, on your microscopes, you have a condenser underneath the stage. Guess who invented the condenser? A guy named Abbe. Some people call it the substage condenser. But that's what it does. It condenses the light. So when the light comes from the lamp at the bottom of the microscope, it enters the condenser. The condenser condenses the light and concentrates it into a beam that goes up into the lenses. That improved microscopy by improving the quality of the light. Because if you condense the light, concentrate the light, it's a better quality light. So it made microscopy better. So one of the ways Abbe improved microscopy was by inventing the condenser. So if here's your lamp,